Now there's another type of strain that sometimes may not be apparent at first, and that is due to the Poisson effect. So if we take that same tension member, and this time we install 2 strain gauges on it, one along the length of the tension member and one turned transverse, and we were to apply the same load, sure, we would still get the same axial load in the x direction, but what would we measure in the y direction? Well, what you would find is that that's a function of the material properties, and it's Poisson's ratio. So there is a strain present in that transverse or y direction, but there's no force in that direction to cause that dimensional strain change. But if you were to glue a strain gauge on it, you could certainly measure it. So this would be a case where basically you've got a strain present, but no stress that's causing it in that direction. Now, where this is useful is that sometimes you may need to characterize a new material, and you could use strain gauges to establish what that Poisson ratio is. It's just the ratio between the strain in the y direction divided by the strain in the x direction. It's really that simple. So it requires 2 strain gauges, or one, what we refer to as a 2-element T rosette, in order to get that measurement. You also may find that in some applications you're using strain gauges to build a transducer. You're not so concerned about what the strain is, but you're trying to get an electrical output as a function of a known mechanical load input. And in some cases, you want to try to maximize that output. And one of the ways to do that is to put on more than one strain gauge. And this would be a real typical example of what a tension link would look like. Here we only show 2 gauges, but you may install another 2 on the back side and build a full bridge. And you've got your 2 gauges along the axis contributing, as well as the 2 that are transverse contributing to the total response, basically to build a better transducer.